Okay, so now we continue with one-dimensional displacement velocity, vector quantities. The motion of an object is completely known if its position is known at all times. Okay, so if we know where on the XY axis that the object is, we can know exactly what its position is. If we consider a truck moving along a highway, the truck's position is defined at some point X at some point T for time. So now we have distance and time that we're bringing into the equation, into the relationships. We have, as we said before, an initial position where the truck starts, X sub I, at some time T sub I. And so T sub I, generally speaking, with an initial value problem, is going to be at 0 seconds, because T is really defined in that small increment of time in seconds. The final position, X sub F, is then at some time final. So it could be 10 seconds later, a minute later, whatever. So we're going to use X and T to determine the displacement and now the velocity being distance per unit time, into our relationship. So now we have an interval of time that we define as a delta factor. Delta T is equal to the difference in T sub F and T sub I. So T sub F minus T sub I, and a displacement delta X, X sub F over X sub I. So you can see now what we're going to do, since velocity is distance per unit time, we're going to combine them into a quotient. So the definition of the average velocity, the difference between initial and final, the average velocity is defined then as the displacement, delta x, divided by the time interval, delta t, during which the displacement occurs. So you can see now we're expanding that relationship. Now you'll notice we have a little v for velocity with a hat on the top of it with a bar. That's telling us we're looking for the average because we're measuring it across 2 points. So delta x divided by delta t is equal to x sub f minus x sub I divided by t sub f minus t sub I. The average velocity then of an object can be either positive or negative depending on the sign of the displacement. The time interval, though, delta t, is always positive. If you ever give me an answer that has negative time, it's going to be wrong. Not unless you've got a Wayback Machine or something that you can go back in time, do you get a negative. So if you get a value of negative time, you've done something wrong. So if we look at a car example, a car moves from a point 100 meters from the origin to a point 50 meters from that origin in a time interval of 2 seconds. Okay, so those are our knowns. Point 1, 100 meters, point 2, 50 meters across 2 seconds. So now if we look at the relationship then that we just defined, we've got terms for every one of those. And you say, well, no, we don't. Where's time initial? Well, time initial, as I said, generally starts off at 0 seconds. So we have 50 meters as the final, minus 100 meters, which is our initial, divided by 2 seconds, which is final, and our initial time, 0 seconds. So now you can see we've got a case here now where we've got a negative value, minus 50 meters divided by 2 seconds. The minus 25 meters per second solution now, which is the average velocity, is a motion to the left. And generally that means that we've got possibly something slowing down, especially in acceleration. So it's important to understand the vector nature of a velocity. Another example, a friend taking a trip in her car will travel at a constant rate of 55 miles per hour. Notice our units here. We're not in meters per second here. We're in miles per hour, mph, in a straight line for 1 hour. So the question to be answered is, where will she be in an hour? So 55 miles from her starting point is where she's going to be. but we don't have enough information. We don't know anything about the direction. It could be, if you think about it as a dot in the middle of a circle, we've got a radius now of 55 miles where that car could be. We don't know, did it go north, south, east, west, northeast, northwest? We don't know. So there's not enough directional information given in this description. However, if she travels 55 miles per hour directly northward, think of it on the XY axis, we're going straight up the Y axis, 55 miles per hour directly northward, her final location can now be known. Okay, because we now know that she traveled in 1 hour that 55 miles. Therefore, the velocity of an object is known only if its direction and its magnitude are specified. Any physical quantity that is a vector must be characterized by both magnitude and direction. So let's take a look at another example. A truck moved 100 meters to the right, that's positive, in 5 seconds. So we go back to our definition. Velocity is equal to delta x over delta t. We weren't given initial and finals. All we know is that it moved 100 meters in 5 seconds. So if we take 100, put it in the numerator, 5 seconds, put it in the denominator, we now have a meter per second and a value of 20 meters per second. Okay, so now we have a true vector. Note that the units of average velocity are units of length divided by time. If we go back to our analysis, dimensional analysis, that's L over T. Recall this from our study. In SI units, we always refer to meters per second. A problem can be given in feet per second or centimeters per second, and depending on what the problem asks you, you may have to do some converting. So let's take a look at one more here, a drag racing example. Notice here that we've got 2 cars that start at point P and go to point Q. We can see on the straight line graph, one on the straight line, one on a curved path. Both have the same displacement. The final point, x sub f, minus x sub I, and then the time interval given as delta t. They both got to from the initial point to the final point, P and Q, but they both covered it in different paths. So we've got the same displacement, although the distance that one went is a little longer than the distance the second went. Confused football player example. The confused football player clearly traveled a great distance of 200 yards, yet his displacement is 0. Why? Because he ended up back where he started. If we look at the definition, x sub f and x sub I are at the same place. So although he did cover a distance, his displacement is 0. So you need to keep this in mind when you're doing problems. Are they asking you for the distance, or are they asking you for the displacement? All right, when we come back, we'll start looking at some graphical interpretations then for velocity to help us solve problems.